Welcome to this video. So in this video, we are going to discuss how to decompose partial fractions. Okay, so the first question someone might ask is, what is the decomposition of these partial fractions? Okay, so the decomposition of partial fractions is simply the breakdown of partial fractions into its parts. Okay, so for example, if I have this fraction, okay, let me say a divided by, okay, let me say in this form, let me say a plus b, okay, divided by c. So if I want to decompose this fraction into its partial fractions, I'm going to say this is the same as a over c, and then plus b over what? C. So this is what we are going to be doing in this video, okay? We're going to be taking a complex or a whole fraction as a whole, and then we decompose it into its part, okay? Okay, or we decompose it into the part that makes it up. Okay, so before we can even solve any equations, we have to understand the rules that we need to use when we are what? Decomposing, okay, partial fractions. All right, so the first rule, whenever you're decomposing partial fractions, the first rule that you have to take note of, okay, is to look at the highest degree of the polynomial in the denominator and in the what? Numerator. Okay, so let's say I have a function of f of x on top, and then I have a function of g down there in the numerator. Okay, so this function, you look at the highest degree that it has, and then you also look at the highest degree that the function of g has. Okay, so if the numerator has a power, okay, that is equal or greater than the power of the denominator, okay, then before we can even decompose that fraction, we first have to use long division. So we would have to divide this denominator into the numerator, okay, and then the results that that we get after we divide are the ones that we're going to decompose into the what? Partial fractions. So that is always the first step. You check the degree in the numerator, and then you check the degree in the what? Denominator. So for example, okay, I can write 2x squared plus 5x divided by 2x squared, maybe minus x. Okay, so you check the degree, okay, the highest degree of, or the highest power in the numerator. The highest power is what? 2. Even here, the highest power is 2. So we said if the degree of the numerator is equal to the degree of the denominator, or the degree of the numerator is greater than the degree of the numerator, we first have to do what? Long division. Okay, so you use the same long division that we did under what? Polynomials. Okay, and then after you do that, the answer that you're going to get is the one that you're going to decompose. Okay, so even if we had something like 3x, 3 to the power x, maybe plus 7x, divided by x squared plus 5x. Okay, we see that the degree of the numerator is bigger than the degree of the what? The denominator. So there we first have to use long division. Okay, and then the answer that we're going to get is the one that we're going to do what? Decompose. So we're going to solve the question based on that when we start looking at these questions that I've put there. Okay, don't worry, you're going to know how to do it. Okay, but that's the first thing that you look at. So if you look at the degrees of the numerator and the degrees of the denominator, okay, if the degree of the numerator is less than the degree of the denominator, then you can go on and decompose your partial fractions. Okay, so for example, if I have x there plus 1, and then in the denominator I have x squared plus maybe 5x, okay, we see that the degree there in the denominator is greater than the degree in the what? The numerator. So we can decompose this. So once you go through the first step, okay, your focus should shift to the what? To the denominator. Denominator, okay? The focus should shift to the denominator. So we have about 4 types, okay? Or we have 4 types of denominators. So each denominator has a unique way in which we are supposed to do what? To handle it. Okay, so let's say we have f of x, okay, and then the denominator is just a denominator of linear factors, maybe say x minus b, okay, and x plus A. Okay, so for us to decompose such, we're just going to say A over the first linear factor plus B over the what? The second linear factor. Okay, and then we can apply the manipulation that we're going to be doing to decompose that fraction. All right, so this is the first type of denominator where we have the linear factors. Okay, so first, and then second, it's a denominator that has repeating linear factors. Okay, so if I have f of x on top, a function of x, and then I have maybe x plus c squared, and then I have x minus d. Okay, so how do I handle this repeating factor like that? Okay, so what you do there is you say a over this same factor, okay, but without the 2. So you put the factors to be in increasing power. So the first one will be x plus c to the power 1. The second one will be x plus c to the power what? 2. Okay, so it will be b over x plus c, and then to the power 2, and then plus c, and then we put now this one. Okay, so if this was power 3, then we would say, first of all, it would be power 1, and then I have another one with power 2, and then another one with what? Power 3. Okay, so this is the second type of denominator that we are going to have. Okay, and then the other one is a situation where we have a denominator, okay, that has a quadratic function which is not factorizable. So f of x is equals to, maybe you have something like x squared plus a. Okay, you can factorize this thing. Okay, we also have x squared maybe plus b. We can factorize this thing. So how do we decompose such? Okay, how do we decompose such? Okay, so if we have such a denominator such that the denominator is not factorizable, okay, then our decomposition will be in this case. Okay, remember when we had linear factors down here, what we are putting on top here were just constants, but now we have a quadratic function which is not factorizable. So what we will be putting on top will be a linear function. Okay, so we are going to say ax plus b divided by the first unfactorizable quadratic factor plus cx plus b divided by the second one. So that's how we are going to be handling unfactorizable what? Factors. Okay, so and then we have another one where now we combine all the three. Okay, we combine all the three. We can combine the linear one with the repeating one. We can also combine it with the what? The unfactorizable factor. So for example, I can have f of x having, okay, x minus a, this one is linear, and then I have x squared plus c, this one is unfactorizable, and then I also have x plus b, maybe squared. So this is a repeating. So how are we going to handle this? So this one is just going to go with the a plus this one, since it's quadratic, which is unfactorizable, it will be b squared x plus c. So these numbers here, the letters here, you can choose any, okay, and then x squared plus c. And then this one, which is repeating, we're going to say d over x plus 1, x plus b to the power 1, and then plus e, and then now we put x plus b squared. Okay. So those are basically the rules that we're going to be using when we are decomposing these partial what? Fractions. Okay, so now let's look at some of these questions so that the concept that we've learned, okay, can sink in into our heads. Okay. All right. So now let's solve some of these questions that we can see here. Okay, let's solve some of these questions that we can see here. Okay. Right. So we are solving questions on partial fractions. So the first one, A, is 3x plus 7 divided by, I have x, then x plus 2, and then x minus 1. So the first thing is to check if the highest power of the denominator is actually greater than the highest power of the what? The numerator. So here the highest power is 1. But in the denominator, when I multiply x with this, I'm going to get x to the power 3. Okay, so the highest power in the denominator is greater than the highest power in the numerator. So there's no need for long division here. We can just go on and what? Simplify it. Okay. So these ones here, we notice that they're just linear factors. Okay. So it will be A over X plus B over X plus 2 plus C over X minus what? 1. All right. So this whole thing here is equals to this. Okay. So now how are we going to handle it? So let me write it here. So it will be 3x plus 7 over x plus 2, x minus 1 is equals to what we have here, a over x plus b over x plus 2 plus c over x minus 1. So from here, okay, I'm going to multiply this whole thing with this denominator. So x plus 2, then x minus 1. So if I multiply this whole thing with this, okay, it's going to cancel out with this. So what I'll get there will be this. Okay, so what I'll get there will just be 3x plus 7 is equals to, okay, if I multiply this factor with this, the x and the x is going to cancel. So it will be a multiplied by what I have there. Okay, so that's what I'll write there. So I'm going to say a multiplied by x plus 2 and then x minus what? 2. Okay, to be plus b. So this factor, when it multiplies this, the x plus 2 cancels. Okay, so we are remaining with x and then x minus 1. Then plus c. If I multiply this with this, the x minus 1 will cancel. So I remain with the x and then x plus what? 2. So this is now the equation that I have there. Okay, that is the equation that I have. So from there, we're going to say, okay, so you have x plus 3x plus 7 is equals to, okay? So here, we want to solve for the values of A, B, and C. Okay, so we can try to eliminate 2 of these. Okay, we can try to eliminate 2 of these. That is the first method that we can use. Or we can just expand, okay, and then equate whatever has x to 3x, whatever does not have x to what? To 7. Okay, so we can use 2 methods here. So let's use the one for expansion. Okay, let's use the one for expansion. So here to be A, and then this here, when I expand it to be x squared. Okay, so this is 1, not 2. Okay, to be x squared, and then x multiplied by minus 1 to be minus x, then 2 multiplied by x to be plus 2x. So this will just be plus x. And then 2 multiplied by minus 1 is minus 2, plus here to be b. And then there I have x squared minus x plus, then there to be c, here to be x squared plus 2x. Okay, so it will be 3x plus 7 is equals to, here I can expand this a into this. So it will be ax squared plus ax minus 2a plus bx squared minus bx, I mean, plus cx squared plus 2cx. All right, so we can group them now. Whatever has the squared, we group them with what has squared. So this one has squared, this one has squared, this one has squared. So we can factorize the x squared. So it's going to be a plus b plus c and then x squared. Okay, let's group the ones with the x. So we have this, and then we have that. So that will be a minus b and then plus 2c x. Okay, and then the ones that do not have any x, we have minus 2a here. Okay, so I'll just write minus 2a here. Okay, is equals to this. So here we can even add plus 0x squared. So it means whatever has x squared is going to be equated to what? To 0. Okay, because we can't see any x squared on the right-hand side. Okay, so it will be 0 is equals to, this is x squared, this is x squared. So 0 should be equals to this. So a plus b plus c. Okay, and then 3 should be equals to this, which is the coefficient of x. So it is 3 is equals to a minus b plus 2c. And then 7 should be equals to the one that does not have any x. So minus 2a is equals to 7. So this means a is equals to 7 over 2, but a minus there. So found already the value of a. Okay, and then we can use the value of a to find the value of b and c. So from here, we are going to say 0 is equals to, the a is minus 7, okay, minus 7 over 2 plus b plus c. So this will simply mean what? It simply mean b plus c is equals to 7 over 2. Okay, and then from here, it will be 3 is equals to, this one here, it is minus 7 over 2 minus b, and then plus 2c. Okay, so we can solve that. So we can take this minus 7 over 2 to the other side. So it will be 3 plus 7 over 2, which will just be 2, 6 plus 7, which will just be 13 over 2. Okay, so this one will be 13 over 2 is equals to minus b plus 2c. So this is the other equation that we have. Okay, so let's solve them simultaneously. Let's solve this one and this one simultaneous. Okay, so we can say from here, we can say that b is equals to b is equals to 7 over 2 minus c. So where there's b here, I'm going to put 7 over 2 minus c. So it will be 13 over 2 is equals to minus the b is 7 over 2 minus c, and then plus 2c. So this will be 13 over 2 is equals to minus 7 over 2 plus c plus 2c. Okay, so this will give me what? To give me minus 13 over 2 plus 7 over 2 is equals to 3c. Okay, so we can add those. So the common denominator is 2 to be 13 plus 7 is equals to 3c. So this will be 20 over 2 is equals to 3c, which will just be 3c is equals to 10. So c is actually equals to 10 over what? 3. Okay, so we found the c. So the remaining one now is just the b. Yeah, the remaining one now is just the b. Okay, so we can erase this part. So let's write what we found so far. A, we found it is minus 7 over 2. B, found it's 10 over 3. I mean C, not B. Okay, so C, we found it's 10 over 3. So now we can find our what? Our B. Okay, so B, okay, B, it's simply equals to 7 over 2 minus C. C is 10 over 3. Okay, so the common denominator here will be 6. 2 into 6 is 3. 3 multiplied by 7 is 21 minus 3 into 6 is 2. 2 multiplied by 20, 2 multiplied by 10 is 20. So this will be 20 is equals to, so I have 1 over what? 6. So B, I'm finding it's 1 over 6. All right, so I found my C, I found my B, and I found my A. So I can now write that equation in its decomposed form. So remember, we said this guy here, okay, said this guy here was the same as A over X plus B over X plus 2 plus C over X minus 1. Okay, so I'm going to say equals here. So my A, okay, my A is minus 7 over 2 over X plus the B is 1 over 6 over X plus 2 plus the C is 10 over 3 over X minus what? 1. So that is what I have there. Okay, so from there, I can multiply, what can I do? Okay, I can just leave it like that, okay, to avoid complications. If you want, you can just leave it like this. So this is the final answer here, okay? But if you want, you can say this one, let me multiply both the numerator and the denominator by 2. So I'm going to have minus 7 over 2x plus this one. I'll multiply both the numerator and the denominator by 6. So I have 1 over 6 and then x plus 2. And then plus this one, I'll multiply both the numerator and the denominator by 3. I'll have 10 over 3x minus what? 1. So this one here is the decomposed partial fractions for what we have on the what? On the first one there. All right, let's look at the second one. So the second one, we have x over 25 minus x squared. All right, so here we might need to factorize the denominator. So this will be x over. So this one here is just the difference of two squares, because this one, the 25 is 5 squared minus x squared. So this one here, when we factorize it, we're just going to get 5 minus x and then 5 plus what? X. So that's what we're going to get there. All right, so we can now decompose this as a over 5 minus x plus b over 5 plus what? X. All right, so from there, we can multiply this whole thing, okay, with the denominator that we can see on the right here. Okay, so we're going to say this whole thing, let us multiply it by 5 minus x and then 5, okay, 5 plus x. All right, so if I multiply this with this, I'm just going to get x is equals to, if I multiply this with this, okay, I'm going to get a 5 plus x, because the 5 minus x will cancel out with this one. If I multiply this with this, the 5 plus x will cancel. So what will remain is it's 5 minus x. Okay, so we can now solve this one. So we can solve this one by expansion, or we can use what? Elimination. So since we have a and b here, so I can eliminate one of these and then solve for the other. So how do I eliminate this? I'm going to say whatever is in the bracket. So I want to eliminate b. 5 minus x is equals to 0. So it will mean that x will just be equals to what? To 5. Okay, so I'll get this x and substitute it into this equation. So wherever there's x, I'm going to put 5. So here to be 5 is equals to a. There to be 5 plus 5 plus b 5 minus 5. So this will be 0. So this part will be eliminated. So I have 5 is equals to this one will be 10a. Okay, so it means a will just be 5 over what? 10, which is 1 over what? 2. Okay, so we found our a to be 1 over 2 by eliminating b. Okay, so we can also do the same. We can eliminate a and then we find our b. Okay, so how are we going to eliminate a? We're going to say let 5 plus x be equals to 0. This one here. So it means x will just be equals to minus 5. Okay, so wherever there's x, I'm putting minus 5 now. So a 5 minus 5 plus b and then 5 minus 5. Okay, so I'll end up with minus 5 is equals to, this one becomes 0. So I have b, then inside there to be 5 plus 5, which will just be 10. So it means b will be minus 5 over 10, which is just minus 1 over 2. Okay, so found b by eliminating a. When we found it's minus half. So we found whatever we need. Okay, we found b, we found a. So we can place it back into this equation here. Okay, so we found that our a is what? Okay, so we can put them there. So we found that our a is 1 over 2. And then our b is minus 1 over what? 2. So we can multiply the numerator and the denominator by 2. So it will be 1 over 2 and then 5 plus x. Oh, that is 5 minus x. Okay, and then this one, this negative with this plus becomes negative. Then I can multiply both sides, both the numerator and denominator by 2. But if you want, you can leave your answer like this. There's no stress. Okay, so it will be 1 over 2, 5 plus what? X. So this one here is the decomposed partial fraction. okay, for what? For this guy that I have on B. All right, so that's it for B. Okay, that's it for B. Then I want to solve a different question. So I want to solve C. So you can try out this one because it has linear factors down there. So we follow the same method that we did on A. All right, so now let's solve question D because it has something different there. So it has a non-factorizable factor. So we have 2x squared minus x plus 3 divided by x plus 1 and then x squared plus 2. Okay, so this is what we have here. So we're going to say this one, when we decompose it, we're just going to have a over x plus 1 plus, okay, this one is an unfactorizable factor. So we have bx plus c divided by what? X squared plus 2. Okay, and then from here, we're going to multiply both sides by this denominator. So x plus 1 and then x squared plus 2. So this one, okay, multiplied by this whole thing, is going to cancel out the denominator. So I'm going to have a 2x squared minus x plus 3 is equals to this multiplied by this, okay? The x plus 1 will cancel, so I remain with a x squared plus 2 plus, okay, this multiplied by this, okay? The x squared plus 2 will cancel, so I remain with bx plus c and then multiplied by x plus 1. Okay, so now let's expand on the right-hand side. So on the right-hand side, we're going to have ax squared plus 2a, okay, plus here we're going to say bx multiplied by this to be bx squared, bx multiplied by 1 to be plus bx, and then c multiplied by x to be cx, and then c multiplied by 1 to be plus c. Okay, so now let's group what we have on the right-hand side. So what we have on the right-hand side, we'll group it, this one with this one. So it will be a plus b, and then ax squared. This one with this one to be b plus c, x, and then the ones without any x to be 2a plus c. Okay, so this will mean that this will equate this will equate that, this will equate that. So we have 3 equations there that we're going to form. Okay, so the first one to just be a plus b is equals to 2. The second one to be b plus c is equals to minus 1. The third one to be 2a plus c is equals to what? 3. Right, so from here, we can get a is equals to b. Actually, it's equals to 2 minus b. Then we get this one, we substitute it into this one. So it will be 2 minus b plus c is equals to 3. So this will be 4 minus 2b plus c is equals to 3. Okay, so this will mean that this is c minus 2b is equals to, this 4 goes to the other side to be 3 minus 4, which will just be minus 1. So we can say c is equals to 2b minus what? 1. Okay, so since I have the value of c, I can substitute it here now. So it will be b plus, the value of c is 2b minus 1, which is equals to minus 1. So this will be 3b is equals to, this one goes to the other side, so it becomes plus. Okay, so it will be minus 1 plus 1, which is just 0. So this means that our b will just be equals to what? 0. Okay, so we found our b to be 0. We can find our c. Okay, since our b is 0, then we're going to say c is just going to be equals to 2, 0 minus 1. So it means c is minus 1. So c is equals to minus 1. And if we have c and b, we can find a. So a is equals to 2 minus b, but b is 0. So it means a is what? 2. So our value of a is equals to 2. Okay, so now we can now put back into the decomposed partial fraction. We're just going to say this is the same as, okay? So where there's a, I put 2 over x plus 1. And then where there's b, I put 0. So this whole thing becomes 0. And then plus c is minus 1 over x squared plus 2. So we can write it as 2 over x plus 1 minus 1 over x squared plus what? 2. Okay, so that's how we solve D there. All right, and then on E, you use the same concept, okay? And then these other questions, I'm also going to solve them, okay? But you can access them on our website, okay? So if you'd like to access the full video solutions, where I'll be solving the rest of the questions, okay? Even the other questions in this tutorial sheet. So you can see this tutorial sheet here, okay? So I've solved all these other questions down here. So you can access them on our website, okay? You can access them on our website and then you'll be able to learn fast and easily, okay? So this has been Decompose Solutions, okay? So thank you so much for watching.